What would happen if you filled the Grand Canyon with Jell-O? The short answer is, you would anger the National Park Service, the U.S. Geological Survey, the Colorado River Basin Water Users Association, and probably every single hiker who had planned a vacation there. Also, you'd create the world's largest dessert-related ecological disaster. Well, that's not quite right either. At the risk of stating the obvious, the real answer is that you'd need an absolutely staggering amount of Jell-O. The Grand Canyon contains roughly 5.45 trillion cubic yards of space. To put that in perspective, if you made regular-sized Jell-O cups, you'd need about 900 trillion of them. That's more Jell-O cups than there are stars in the observable universe, which seems like overkill for a dessert. But let's say you somehow acquired enough gelatin powder. The first problem you'd encounter is the preparation process. Standard Jell-O requires hot water to dissolve the gelatin properly. To make Grand Canyon Jell-O, you'd need to heat approximately 1.4 trillion gallons of water to boiling. This would require more energy than the entire United States uses in about 6 months. The steam alone would create a weather system visible from space, and you'd probably trigger some very confused climate change reports. Then there's the cooling problem. Jell-O needs to be refrigerated to set properly. But the Grand Canyon is in Arizona, where summer temperatures regularly exceed 100 degrees Fahrenheit. Even if you managed to get your trillion gallons of hot Jell-O mixed down into the canyon, it would never set in those conditions. You'd essentially create a massive, warm, strawberry-flavored lake that would smell increasingly concerning as time went on. But let's assume you somehow solved the temperature issue with the world's largest refrigeration system. The sheer weight of all that Jell-O would create some interesting geological consequences. Jell-O is roughly the same density as water, so you'd be adding about 4.8 trillion tons of weight to the Colorado Plateau. This additional pressure would likely trigger earthquakes throughout the region and potentially cause the canyon walls to collapse inward, creating what geologists would probably call a Jell-O basin instead of a canyon. The ecological impact would be catastrophic. The Colorado River, which carved the Grand Canyon over millions of years, would now be flowing through a gelatinous obstacle course. Fish would find themselves swimming through what amounts to a very large aspic. The river's flow would slow dramatically, affecting water supplies for millions of people downstream. California would probably sue Arizona over Jell-O contaminated water rights, creating the most unusual Supreme Court case in history. Wildlife would face unprecedented challenges. Bighorn sheep attempting to navigate Jell-O-covered cliff faces would find their usual sure-footed climbing abilities somewhat compromised. Birds would discover that landing on a bouncy, gelatinous surface creates unexpected aerodynamic problems, and tourists trying to hike the Bright Angel Trail would need completely different equipment, possibly including snorkels and diving fins. The wobbling would be spectacular. Any vibration from a passing airplane to a tourist dropping their phone would send waves rippling through the entire canyon. Seismic monitoring stations across the Southwest would register a constant, low-frequency tremor that scientists would initially mistake for some kind of underground activity, until they realized it was just 5.45 trillion cubic yards of cherry Jell-O jiggling in unison. From a physics perspective, the Grand Canyon Jell-O would behave like a massive non-Newtonian fluid. Under normal conditions, it would act like a solid, but any significant force would cause it to flow like a very thick liquid. This means that if a rock slide occurred on one rim, it might cause a Jell-O tsunami that could shoot up the opposite wall like a gelatinous geyser. Temperature fluctuations would create their own problems. Desert nights can be quite cold, causing the Jell-O to contract, while hot days would make it expand. The canyon would essentially be breathing, expanding and contracting by several feet each day. This would create stress fractures in the Jell-O itself, leading to what food scientists might technically classify as structural dessert failure. After a few months, decomposition would begin. Trillions of cubic yards of rotting gelatin in the Arizona heat would create and smell so powerful, it would be detectable by satellite. The methane production alone might contribute meaningfully to greenhouse gas emissions, and you'd probably receive some very stern letters from environmental protection agencies about your unauthorized dessert installation, in which case you'd be in very, very big trouble with the National Park Service, and they'd probably make you clean it up with a very large spoon.